Okay, so in this question, we have to solve this differential equation, right? And whenever there is a question on solving differential equation, the first thing which you should notice is what type of differential equation is given to you, right? So just by looking at this differential equation, we can say that this is actually of the form linear differential equation. This is the standard form that we already know how to solve, right? This standard form looks like this: dy by dx plus some function of x, let us call that px, into y is equal to another function of x, let us say qx, right? So this form of equation is called linear differential equation. And how to solve this equation? To solve this equation, there is this one quantity called integrating factor, right? And integrating factor value is e to the power integral of px dx, right? Now if you know the integrating factor and the px and qx values, then now you can directly write the solution of this differential equation. The solution of differential equation is directly given by integrating factor, which we just found, into y is equal to integral of integrating factor again into this another function qx dx, right? If you solve this integral, you will get your final solution of linear differential equation, right? So now let us get back to our question. In our question, as we see that this is not exactly given in the linear differential equation form, because the coefficient of dy by dx in standard form is equal to 1, but we have 1 plus x square as our coefficient, right? So first thing that we do is we divide the expression by 1 plus x square. If we do that, then our question converts to this equation: dy by dx plus 1 upon 1 plus x square into y is equal to e to the power tan inverse x upon 1 plus x square. Now this equation is exactly compared to the standard form that we know, which we call linear differential equation, right? So looking at this, I can again find my integrating factor. Integrating factor is e to the power integral px dx. In our case, px is 1 upon 1 plus x square dx, right? Now we already know that 1 upon 1 plus x square integral is tan inverse x. So this is our integrating factor for this particular differential equation, right? So now I am directly using this solution. So to write the solution, I get this equation: integrating factor, which is e to the power tan inverse x into y, okay, is equal to integral of integrating factor, which is e to the power tan inverse x into qx. Now our qx is what? Our qx is this particular portion, which is e to the power tan inverse x upon 1 plus x square into dx. So if we can solve this particular equation integral on the right hand side, we will get our answer. So this integral again looks easy because one simple substitution will make our integral very easy to solve. So here I am substituting e to the power tan inverse x as t. If e to the power tan inverse x is equal to t, then to get dx value, I will differentiate this substitution value, right? So that will give me e to the power tan inverse x into 1 upon 1 plus x square, because that is the differential of tan inverse x, into dx, because this is the differential of x, is equal to dt, right? Okay, so now I already see these terms in my integral. I see this group, which is actually the LHS portion here, right? So this complete LHS portion can be replaced with dt, and the remaining portion e to the power tan inverse x will be written as t, which means that I will get my RHS portion as integral of t dt. That's very easy now. So t dt on integral will become t square by 2, and you can add some arbitrary constant to it, right? And LHS portion is what? LHS portion is what we have: e to the power tan inverse x into y. Now in the end, just replace the value of t with the original value of x, which is e to the power tan inverse x, and that should give you your final result, right? So your final answer will become e to the power tan inverse x into y is equal to e to the power tan inverse x whole square divided by 2 plus c. This now becomes your final answer.